Next, we're going to check the lateral capacity of the ramp walls as shear walls, which is going to be section 2.2 for unreinforced shear walls. Now this check revolves around equation 2-20, FV equals VQ over INB, or 1.5 V, which is the shear force over area, for rectangular sections. And in the previous check, Q, IN, and B are just properties of the section. So V is the shear force, which we'll take as P wall. Q is the first moment about the neutral axis. IN is the second moment about the neutral axis. B is the width of the section, and H is the total wall length at its shortest. This may be confusing at first, but if you look at the diagram, it is actually H, or the full wall length, that is resisting shear, which I've noted here in purple, this section, and this being, kind of an isometric view of the wall. This purple section is actually that shear length, or that H, that's getting resisted, that is resisting being sheared, with B being the wall width, and I marked the front of the anchor and the back of the foundation. And then in section, we can see that the max shear is going to occur in this section in the middle, and that max shear is going to also be our V, which is P wall. Now, section 2.2.5.2 specifies our allowable in-plane shear stress to be under the following conditions. And we'll evaluate it under condition C, which is for running bond masonry that is not fully grouted. Now, stone masonry is placed in running bond. However, we can't assume it is fully grouted. So condition C is calculated as follows. And we'll check that FV is less than or equal to 37 plus NV over AN in PSI, where NV is the compressive force normal to the bond direction, and AN is the total cross-sectional area. We can calculate NV for one wall as P ramp cap divided by 2, so the normal force onto the wall is going to be the weight of the ramp cap divided by 2 as it separates into each wall. And AN will just be calculated as B times H. So it's just B times H, not BH squared. That 2 is for the NV above. And B times H, which is our section. And then the final check is the following. And note that there's no factor of safety specifically applied in this inequality, because allowable in-plane shear stress is provided by ACI with a built-in factor of safety. So we'll be checking this inequality here.